Hello everyone, myself Dr. M. Pavan Kumar Reddy, Assistant Professor, Department of Mathematics, VNR VJEC. Today we learn what is double integral, how to evaluate double integrals. Double integral, evaluation of double integral and few problems. So first, multiple integrals, double integrals. What is multiple integral? As we studied the definite integral, okay, multiple integrals is an extension of a definite integral of a function of single variable to a function of 2 or 3 variables. Okay, we studied evaluation of integral which consisting single variable. Okay, now we evaluate integral consisting 2 variables or 3 variables, which is an extension of definite single integral. Okay, so double integrals occur in many practical problems in science and engineering. So the problems which involves finding area, volume, mass, center of mass, etc. Okay. So what is double integral? Now we'll see the definition. See, double integral. It is consider a function of 2 variables. F of x comma y is a function of 2 variables which are independent variables x and y. Defined at each point in the finite region R of the xy plane. Xy plane means Cartesian plane. Complete. X-axis, y-axis. 4 quadrants we have. That is xy plane we call. So in xy plane, R is the region where we are considering this function f of x comma y. And now the double integral of the function f of x comma y over this region R can be written as double integral over the region R f of x comma y dA. Double integral over R f of x comma y dA. So for evaluation purpose, we can write this integral as double integral over R f of x comma y dA is equals to integral x1 to x2 integral y1 to y2 f of x comma y dx dy. So what is y1, y2 and x1, x2? y1, y2 are the limits of the variable y. x1, x2 are the limits of the variable x. Okay. Now, see, evaluation of double integral. We have 3 cases. We'll discuss one by one. So first, a double integral is computed by repeated single variable integration. That is, while integrating with respect to one variable, we consider the other variable as constant. Okay. See, case 1. What is case 1 is? See here, the region R is a rectangle. Region R is a rectangle. See here, this is the region of integration. Observe here, region is bounded by A, B, C, D. A, B, C, D. AB is a line, BD, CD, AC, which is a rectangle. So the region here is bounded by x is equals to x1 line, x is equals to x2, y is equals to y1, y is equals to y2. So it means all the values here x1, x2, y1, y2 all are constants. This is case 1. So in this case, to evaluate the integral over the region R, double integral over R f of x comma y dx dy, see, we write the integral as x1 to x2, y1 to y2 f of x comma y dy into dx. See here, this is the innermost integral. This is the outer integral. Inner integral, outer integral. Okay. Inner integral is with respect to y. Outer integral is with respect to x. That means first we have to integrate with respect to y, then with respect to x. Since here the integral limits are constants, the order of integration is immaterial. That means you can integrate first with respect to x, then with respect to y also. That means both the integrals gives you the same value. That is, if the integral limits are constants, remember the order of integration is immaterial. Okay, so you can integrate first with respect to y, then with respect to x, or first with respect to x, then with respect to y. Okay, so this is the region of integration. See, what is this is, these are called strips. Okay, PQ, this is one strip. P dash, Q dash, this is called a vertical strip. Okay, this is called a vertical strip. Okay, vertical strip. And this is a horizontal strip. So these helps us in identifying the limits. Of course, if limits are given, it is okay. If limits are not given, we consider a strip in the region of integration and we identify the limits. That we'll discuss later. Okay. So this is case 1. If both the integral limits are constants, we evaluate first with respect to y, then with respect to x. Or we evaluate first with respect to x, then with respect to y. Okay. Case 2, let's see. So what is case 2? Here, the region R is given by, see here, of course, x lying between x1, x2, y lying between y1, y2. But here, the difference is, here x1, x2 are constants, where y1 and y2 are functions of x. y1 and y2 are functions of x, say f1 of x and f2 of x. See, this is a figure. Let us consider that. Here the region of integration is bounded by, see, this is x is equals to x1, which is a straight line, x is equals to x2, which is also a straight line, y1 is equals to f1 of x, y1 is equals to f1 of x, which is a curve, and y2 is equals to f2 of x. This is also another curve. Okay, so the region is bounded by here A, this is the region A, B, okay, this is D, and it is C. This is the region of integration. So here we have to consider vertical strip. Why vertical strip? Why not horizontal strip? See here, generally, how we have to consider a strip in the region is, strip has two ends. Okay, if it is vertical strip, lower end, upper end. If it is horizontal strip, left end, right end. Okay, so now we are where the strip has its ends, are the, in case of variable limits, where the strip has its ends are the variable limits. That means, see here, y f1 of x, f2 of x. This is inner integral. Where the strip has its ends, it represents the inner integral. From where to where it has to move to cover the entire region of integration is called the outer integral limits. So this is vertical strip. It has its ends at P and Q, which is lower end is on f1 of x, upper end is on f2 of x. So these are inner integral limits. To cover the region, the strip has to move from the line x is equals to x1 to x is equals to x2. From here to here, the strip has to move once. If it moves once, it covers the entire region. So those are the outer integral limits. That's why here, see, y1 to y2 f of x comma y dy, and outer integral is x1 to x2 dx. So inner integral limits are variable limits, outer integral limits are constant limits. Remember, first we have to integrate with respect to the variable limits. Later we have to integrate with respect to constant limits. Okay, so here, since y limits are functions of x, first we have to integrate with respect to y, and then we integrate with respect to x. So this is another case. Okay, we'll see another case, that is case 3. That is where this time x1, x2 are functions of y, y1, y2 are constants. That is, see here, here we consider a horizontal strip in the region. See, the region here is, bounded by y is equals to y1 and x2 is equals to f2 and y is equals to y2 and x1 is equals to f1. This is the region of integration. So in this region, we are considering a horizontal strip, since, see here, these are the variable limits. x1, x2 are the variable limits, which are functions of y. We consider a horizontal strip. So strip has its ends on x1 and x2. That is f1 of y, f2 of y. That's why those are the inner integral limits, x1 to x2 f of x comma y dx. That's why we integrate first with respect to x by treating y as constant. And next we integrate with respect to y. See here, to cover this region, this strip has to move from the line y is equals to y1 to y is equals to y2. Once it slides from y1 to y2, it covers the entire region of integration. Okay, so this is, here we integrate with respect to x and then with respect to y. While integrating with respect to x, we treat y as constant, and next we integrate with respect to y. Okay, this is the another case. Okay, let's evaluate one problem. Okay, see, evaluate integral 0 to 1 integral 1 to 2 x into x plus y dy dx. Observe here carefully. See, both are constant limits. But how to identify that? Which are the limits of which variable? That is, so 0 to 1, is these are limits corresponds to x or y? 1 to 2, is this corresponds to limits of variable x or y? So in such case, if you are unable to identify, follow this order of integration. So here dy dx, that means inner integral limits are y limits, outer integral limits are x limits. Okay, that means this is, see, integral 0 to 1, integral 1 to 2, it is x into x plus y dy dx. dy dx. See here, since here it is not mentioned clearly what are the x and what are the y limits, so we follow this order. That means 1 to 2 are y limits, 0 to 1 are x limits. So I'll write like that. So x varies from 0 to 1 and y varies from 1 to 2. Now this can be x into x plus y can be written as x into x square plus x into y xy. Okay, into first with respect to y, then with respect to x. That is, so since here first with respect to y we'll do, next with respect to x. First it is, we are integrating with respect to y now, so we have to treat x as constant. So first x square, then x square is constant. Okay, x square is constant. So integral 1 to 2, 1 into dy, correct? So since we are treating x square is constant, which can be written outside of this inner integral. Next plus, here x is also constant, so we write outside, and inner integral limit 1 to 2, it is y into dy into dx. This is equals to, now integral x varies from 0 to 1. Okay, now see, this is x square. Integral 1 dy is, it is y. Apply the limits, upper limit 2, lower limit 1, plus x into integral y dy. Integral y dy is y square divided by 2. So upper limit 2, lower limit 1. And finally with respect to x. Okay. Now it is integral x varies from 0 to 1. Let's substitute the limits. X square into, instead of y, since we integrated with respect to y, we have to substitute instead of y upper and lower limits. Upper limit is 2, lower limit is 1. Substitute first upper limit, it is 2 minus, so while substituting lower limit we have to consider it is minus substitution of lower limit, instead of y 1. Next plus here x into, instead of y 2, it is 2 square, which is 4. So 4 by 2 minus, instead of y 1. So it is 1 by 2. 1 square is 1 into dx. This is equals to. So integral x varies from 0 to 1. Now let's simplify this. 2 minus 1, it is 1. 1 into x square, which is x square, plus 4 by 2 minus 1 by 2, which is nothing but 3 by 2. So it is 3 by 2 into x into dx. Okay. See, this is equals to integral, okay, x varies from 0 to 1, which is x square plus x square into dx plus integral, applying integral to both the terms separately. Integral x varies to 0 to 1, it is 3 by 2, which is constant, into x into dx. Now it is equals to, let's integrate. What is integral x square? It is x cube divided by 3. Integral x power n is x power n plus 1 by n plus 1. Okay. So it is upper limit 1, lower limit is 0. So for your reference, I'll write the formula here. Integral x power n dx, which is equals to x to the power of n plus 1 divided by n plus 1. Whenever it is necessary, I'll write the formulas beside. Now it is plus 3 by 2, which is constant. Integral x dx is, of course, it is x square by 2. Upper limit is 1 and lower limit is 0. This is equals to Instead of x, substitute 1 and 0. First 1, it is 1 by 3. 1 cube is 1 minus substitution of lower limit, which is 0. 0 divided by 3, which is 0. Next plus, here it is 3 by 2 into upper limit is 1, 1 square is 1, 1 by 2. Substitution of lower limit 0, so it is 0 by something, 0. Now it is equals to, it is 1 by 3 plus 3 by 2 into 1 by 2, which is 3 by 4. 3 by 4. Let's take LCM. LCM is 12. So 3 4s are 12, so 1 4s are 4. 4 3s are 12, 3 3s are 9. So it is 9 plus 4, which is 13 divided by 12. So is the value of the integral. Okay. So if both the integrals are having constant limits, order of integration is immaterial. So here what we have done, first we integrated with respect to y, then with respect to x. Actually, you can do first with respect to x, then with respect to y also. That is just by interchanging these limits, make this x 0 to 1 as inner integral, make y 1 to 2 as an outer integral, and you can evaluate. That you try later. You can check the answer. You will get the same. That is 13 by 2. So, okay. So this is when limits are given, this is the way to evaluate a double integral. Suppose if the limits are not given, how to identify the limits and how to evaluate the integral? We'll see one. Okay, we'll see one more problem when integral limits are variables, not constants. Okay, we'll see one more problem. So here observe the inner integral, both the integral limits are 0 to a and 0 to root over a square minus y square. Here both the integral limits are not constants. This belongs to, say, case 3. So inner integral limits are functions of y, outer integral limits are constants. So in this case, irrespective of this you don't follow this one. You have to follow this. Since the inner integral limits are functions of y, means these are must be y limits. Of course, here it is given dx dy, so no issue. But if it is, sometimes it may be given dy dx also, don't consider these are y limits. Y limits never be a function of y. Okay, so x limits are functions of y. Then obviously these are y limits. Okay, now we evaluate this one. So now consider the left hand side. Consider the integral 0 to a, integral 0 to root over a square minus y square, root over it is a square minus x square minus y square into dx dy. This is equals to. See here, as we know, these are the y limits. So y varies from 0 to a. Okay. And it is x limits. X varies from 0 to, it is root over a square minus y square. See, inner integral limits are functions of y. Those are x limits. Now, let's rewrite this integrand as, see it is, since we have to integrate first with respect to x, then write this one as a square minus y square minus x square into dx into dy. Okay, I'm writing like this. Okay, now this is equals to integral y varies from 0 to a, and this is integral x varies from 0 to root over a square minus y square. Since we are integrating with respect to x, so we treat y as constant. So a square constant, y square constant. Let's write this one in the form root over a square minus y square whole square minus x square into dx into dy. Okay, into dx into dy. Now observe, it is in the form root over a square minus x square. It is in the form root over a square minus x square. Since we are treating y as constant, this entire term is constant. Let us assume that this is some a square minus x square. What is the formula for root over a square minus x square? So root over a square minus x square integral root over a square minus x square dx formula is x by 2 root over a square minus x square plus a square divided by 2 into sine inverse of x by a. X by a. What is a? Okay, a. This is actually the formula. Okay, integral root over a square minus x square dx formula is x by a. Okay, x by a, sorry, x by a root over a square minus x square plus a square by 2 sine inverse of x by a. This is the formula. Let's apply this formula here. Now, we are integrating now with respect to x. See, x by a. Here, if you compare these two, x is equals to x only, but a is equals to, this a equals to root over a square minus y square. Root over a square minus y square. That means x by a. What is x by a? X by a means x divided by a. What is a? A is root over a square minus y square. Root over a square minus y square. Into root over a square minus x square. Root over a square. A square means instead of a square we have this one now. So it is a square minus y square whole square minus x square plus a square by 2. What is a? A is this one. So it is a square means a square minus y square whole square. This is a square by 2 into sine inverse of x by a. What is x? X is x itself. A is root over a square minus y square. This is. Okay. What is upper limit here? It is root over a square minus y square. Lower limit is 0 into dy. Into dy. So this is equals to. So integral y varies from 0 to a. Let's substitute the limits. Instead of x, root over a square minus y square. Since we integrated with respect to x, instead of x, we have to substitute this. If you substitute this root over a square minus y square, what happens here? Root over a square minus y square by a root over a square minus y square, which is 1 of course. But here, a square minus, this is, instead of x, we are substituting this same. Observe here carefully. Root over a square minus y square, we are substituting here. So, root over a square minus y square whole square, root over a square minus y square whole square. So, a minus a, 0. Root over 0, 0. 0 into something, 0. So, no contribution of this term. No contribution of this term. Similarly, plus, here we substitute now. It is root, square root and square gets cancelled. This is square and square root cancel. So that we have a square minus y square divided by 2. Okay. Into which is sine inverse of. What is x here? X is equals to root over a square minus y square divided by root over a square minus y square. Root over a square minus y square. Since we are substituting lower limit, so minus x equals to 0. Here it is 0. 0 into anything? 0. So no contribution of this term again. So this term completely does not have any contribution for both upper limit as well as lower limit. Okay, next minus. Substitution of lower limit. So again, so minus into this plus minus. This is a square minus y square divided by 2. It is sine inverse of x is equals to 0. 0 by something? 0. 0 by something? 0. Into dy. Into dy. This is equals to. Now, integral y varies from 0 to a. 0 to a. Let's simplify this. So here a square minus y square by 2. Here a square minus y square by 2 we have. So let's take a square minus y square by 2 common. Into this is sine inverse of 1. This is sine inverse of 1. Numerator and denominator same, gets cancelled. Minus this is sine inverse of 0. Sine inverse of 0 into dy. Into dy. Now this is equals to Here integral y varies from 0 to a. 0 to a. What is sine inverse 1? So we have to express this 1 as in terms of sine. Sine 1 can be written as sine pi by 2. 1 can be written as sine pi by 2. That is, so a square minus y square divided by 2 into sine inverse of sine pi by 2. See, I am using this space for rough. So it is sine inverse 1 can be written as sine inverse of sine pi by 2. That means sine inverse cancel, we have pi by 2. Similarly, sine inverse of 0 can be written as sine inverse of sine 0. So it is cancelled, so 0. That means here it is pi by 2 minus 0 into dy. Now, see here, this is equals to. Now integrating with respect to y. Pi by 2 minus 0, pi by 2 which is constant can be written outside. Now a square minus y square by 2. Let's integrate this one. See, this 2 also I am writing outside, pi by 4. Okay, a square minus y square by 2 into pi by 2 minus 0. No, pi by 4 I am writing outside. Let's integrating a square minus y square with respect to y. That means it is a square into y. A square constant, integral 1 dy is y. Minus y square integral is y cube divided by 3. Upper limit is a, lower limit is 0. This is equals to pi by 4. Let's substitute now. Instead of y, we have to substitute the limits. Upper limit is a square into a, which is a cube, minus, instead of y, it is a cube divided by 3. Substitution of lower limit, minus 0, instead of y 0, it is 0, no contribution. Substitution of lower limit, minus, into this minus becomes plus. Here it is 0, no contribution. That is equals to, it is now a cube minus a cube by 3. I am writing directly, 3a cube minus a cube is 2a cube by 3. So it is, so pi by 4 into, this is 2 into a cube divided by 3. Making cancellation, which is pi by 2 to the 4. So the answer is, it is pi a cube divided by 6. So this is the answer. So if the integral limits are variable limits, so then first we have to integrate with respect to the variable which has variable limits. Then we integrate with respect to the variable which have constant limits. Okay, so this is if the problem is given variable limits, we have to evaluate like this. Let's see. So far we have discussed if the limits are given, how to evaluate the double integral. Suppose if the limits are not given, but say the region is bounded by some curves or lines is given, then how to identify the limits? Okay, first we have to identify the region of integration, then identify the limits, and we evaluate in the similar manner. Okay, let's go to the next problem. See, this is, it is. Now we evaluate a problem which limits are not given. The region is bounded by some curves. Let's see. See, so region here, what is given is, given that the region R is bounded by, first, what is that? It is x-axis. X-axis is nothing but y is equals to 0 and the line x is equals to 2a and parabola which is x square is equals to 4ay. Okay, let's identify the region of integration. Okay, say this is x-axis, this is y-axis, x-axis, y-axis. Now, y equals to 0 means, of course, y equals 0 means x-axis. X is equals to 2a. X is equals to constant is a straight line which is parallel to y-axis. Okay, so therefore, let us consider somewhere here it is a and somewhere here it is say 2a. So, I am drawing a line x is equals to 2a. This is the line x is equals to 2a. x is equals to 2a. Now this is x square equals to 4ay is the standard parabola curve. So let's draw the parabola. It is this is the parabola, which is x square equals to 4ay. X square equals to 4ay. Okay. Now what is the region here? Carefully look at it. X-axis, y equals 0. X equals to 2a. X equals to 2a line. And the parabola. That means this is the region of integration. 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 So now, how to identify the limits? So here, observe, we have to consider either vertical strip or horizontal strip. Either strip you can consider. You can consider a vertical strip to identify the limits or horizontal strip to identify the limits. Okay. See, let us consider a strip in the region. So, which strip we consider? Let us consider that we consider a vertical strip in the region. Let us consider a vertical strip in the region. So, let us consider this is the strip I am considering in the region. So, vertical strip we are considering means those are where the strip has its ends are the y limits. So, strip has lower end, upper end. So, lower end is moving on, y is equals to 0. So, now I am writing the limits in blue color. So, y equals 0. Upper end of the strip is moving on the parabola. So, the parabola equation is x square equals to 4a by 4ay. We have to express this in terms of y in terms of x. That is, y is equals to x square divided by 4a. So, y limits are 0 to x square by 4a. Y limits are 0 to x square by 4a. These are the y limits. Okay. So, vertical strip means y limits are functions of x or y limits. Vertical strip means where the strip has its ends represents y limits. Okay. Now, to cover this region, this strip has to cover the entire region. To cover this entire region, this strip has to move from the line y-axis to see the region of integration is up to this point we have. This is the entire region of integration we have. So to cover this region, this strip has to move from the line y-axis. Y-axis means x is equals to 0 to this is the line x is equals to 2a. So to cover the region, the strip has to move from the line x is equals 0 to x equals to 2a. So those are x limits. So this is the way to identify the y and x limits. So now here I am writing the limits in blue color. So here y varies from okay 0 to x square divided by 4a and x varies from 0 to 2a. So now we got y limits as well as x limits. Now we can evaluate the integral. Let's see. Okay. So I'll explaining once again. Let's see. First step is identifying the region of integration. That is region of integration is R bounded by x-axis y equals 0, parabola x square equals to 4ay and the ordinate x equals to 2a which is parallel to y-axis. So this is the region of integration. So for evaluation, let us consider a vertical strip in the region. So vertical strip where the strip has its ends, lower end of the strip is moving on y equals to 0, upper end of the strip is moving on x square equal to 4ay. Let's represent it in the form y in terms of x. That is y equal to x square by 4a. Those are y limits. To cover the region, this strip has to slide from the line x equals 0 to x equals to 2a. Okay. Now evaluating. So therefore, double integral over the region R, it is xy into dx dy which is equals to, now since the constant limits can be written outside, so x varies from 0 to 2a, okay, and y varies from 0 to x square divided by 4a, and this is xy. See here, even though here it is given dx dy, first since y limits are functions of x, first we have to integrate with respect to y, so dy and then dx. Okay, So first we have to integrate with respect to y now. So in x varies from 0 to 2a. Integrating with respect to y, so we treat x as constant, and y integral is y square by 2. Integral y dy is y square by 2. So upper limit is x square divided by 4a and lower limit is 0 into dx. This is equals to, say, integral x varies from 0 to 2a. It is x into, instead of y, since we integrated with respect to y, we have to substitute the limits in the variable x. In the variable y. Instead of y, x square by 4a. Remember, instead of y, x square by 4a. That means x square by 4a whole square. X square by 4a whole square means x square whole square is x power 4 divided by 4a whole square is 16a square divided by 2 minus substitution of lower limit, which is 0, no contribution, into dx. Okay. Now let's simplify this one. This is equals to, integral x equals to 0 to 2a. Integral x varies from 0 to 2a. So it is x into x square by 4a, x power 4 by 16a square by 2. So this is 16a square by 2 means this is 32a square actually. This x power 4, this is denominator, this is denominator. If you consider this is x power 4 by 32a square, x power 4 into x is x power 5. So which is x to the power of 5 divided by, if you multiply, it is 32a square. 32a square into dx. Next, integrating with respect to this 1 by 32a square constant outside, integrating x power 5 with respect to x. X power 5 integral is x to the power of 6 by 6. Upper limit 2a, lower limit 0, which is equals to 1 by 32 into a square. Let's substitute instead of x 2a. 2a whole power 6. 2a whole power 6 divided by 6 minus substitution of lower limit, which is 0, no contribution, which is equals to 1 by 32a square into 2a, 2 power 6. See, 2 square 4, 2 power 3 8, 4 16, 2 power 5 32, 2 power 6 is 64. So it is 64a to the power of 6 divided by 6. Let's make it cancellations. So 32 2 ja 64 and a square cancel. So finally we get the answer as a to the power of, this is 2 3 ja. So therefore a to the power of 4 divided by 3. So this is the value of the integral. Okay. So evaluate double integral over r xy dx dy, where r is the region bounded by x-axis, ordinate x equals to a, and the curve. So first we identify the region of integration and then consider either vertical or horizontal strip in the region. Okay. And then determine the limits and evaluate. Okay. See here, not only we have to consider the vertical strip, you can consider horizontal strip in the region also. You can consider horizontal strip. So if you consider horizontal strip, so what happens? See here, if you consider a horizontal strip, I'll explain here. Suppose if you consider the region of integration here like this, just roughly I am explaining. This is x-axis, say this is y-axis. Okay. And this is the parabola we have, and this is the line x is equals to 2a. And this is x is equals to 0. And this is y is equals to 0. And this is the x square equals to 4ay parabola. This is the region, of course, the same. Okay. But instead of considering a vertical strip, you are considering, say, horizontal strip in the region. If you consider horizontal strip in the region, what happens? If you consider horizontal strip, you have to consider the limits as x limits in terms of y. That means here you have to express this parabola as x is equals to 2 root ay. Okay. X square equal 4ay. X equals to square root, apply square root on both sides. Root over 4ay, 2 root ay. So the limits are now x varies from 2 root ay to 2a. Left end of the strip is moving on 2 root ay. Right end of the strip is moving on 2a. So x limits. And y limits are, y varies from 0 to lower end. To cover this region, the y has to vary from 0 to this point, of course. So first we have to determine this intersection point. How to determine intersection point? So this is the intersection point of this straight line and this parabola. So put x equals to 2a here. If you put x equals to 2a, what happens? It is 2a square. It is 4a square equals to 4ay. That means 4 cancel, 1a cancel, so that y equals to a. That means that here the coordinates are x coordinate is 2a, y coordinate is a. It means that here this is the straight line, y is equals to a. So to cover this region, the horizontal strip has to move from the line y equals to 0 to y equals to a. So y varies from 0 to a. Okay, I am leaving this as an exercise. So consider these limits and evaluate, check whether you are getting the same answer or not. Okay, so this is if the limits are not given, identifying the limits and evaluating double integral. Okay, let's work out these problems. Okay, so the first one is variable limits, and this is also a variable limits problem. Okay, of course this is also try to work out this. This is the limits are not given. Try to identify the region of integration and evaluate the integral. Okay, so this is, thank you. So if you have any queries, feel free to contact me on this mail. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.